Alright guys, so we're still on section 1.1 and section 1.1, and now we're going to talk about sets and intervals. So a set is a collection of objects, and the objects are just elements of the set. So I could even have like a set of oranges, a set of numbers, a set of the even numbers, or just different things. So we've already seen that this symbol means it's A is an element of S. If it's not an element, we just cross it out. So S is our set. Okay, so for example, 4 is a set of the integers. Pi, we know, is not a set of the integers. Pi is an irrational number. So say another example is we wanted to define the set of integers, but we want them to be positive, and then we want them to be less than 3. So that we have A as our set. So a number that's less than 3 but positive are 1 and 2. We could also describe this in set builder notation. So that's like this. So we have A is equal to X. This line means such that X is an integer and that it is between, it's positive, and it's between 0 and 3. Alright, now we're going to talk about unions and intersections. So we have union. So if S and T are sets, S union T is a set that consists of all elements in S or T, or both. And then we have the intersection like this. That means that we're looking at elements in both S and T. So I remember these because union is like a U. So the S union T, it's already looking like a U there. And then union is like a marriage. So union is marriage. And then intersection is like a road. So intersection is like what's in common. What's in the intersection of the road. Marriage is like you're having two different parties joined. And then our empty set is like this. Oops, that does not look good. I'll do it a little bit clearer so you guys can see it. So it's like a circle and then slash. So that's the set with no elements, so it's empty. Okay. I'm going to stop real quick so I could show you guys a picture. Alright, so this is a picture of a Venn diagram. So these are really helpful for understanding unions and intersection and complements. So A union B is elements that belong to either A or B. So everything's kind of highlighted there. A intersect B is elements that belong to both A and B. So that's the overlap. So even if you look up Venn diagrams for unions and intersections, you could always find your favorite one. So this is just one that I like. And then U is called the universal set. Alright, so we'll go ahead and do some examples. So suppose S is 1, 2, 3, and pi. T equals 3 pi and 6. B equals 2, 22, 14. So we want to find S union T, S intersect T, and T intersect B. So go ahead and pause the video and see if you could find these out. Okay, hopefully you were able to figure it out, but here you go to check your answers. So we want to look up things that are in S or T or both. So 1 and 2 are in S, 3 are in both S and T, and so is pi. And then 6 is in T. So S intersect T, we want to look for things that are in both. So that's 3 and pi. And then T intersect B, are there any elements that are common between these two sets? No. So it's the empty set. Okay, so we'll go ahead and move to intervals. So intervals, there are open intervals, so that's represented with parentheses, and that's with A less than B here. And then closed, I like to think of closed like it's closed like a box. That's why it's square like that. And A is also less than B. So just drawing a picture here with a line for both. So we have A and B, A and B. So drawing this, when it's an open, so we have an open dot on both. When it's closed, it's a closed dot. That means that it's included. So here, like A and B aren't included in the interval. And then in closed, they are included in the interval. That's why we have the dot. So some challenge to do is to try and write these sets in set builder notation and see if you're able to do that. Oops, getting emails from Cal Poly, like everyone is this week. Okay. So if you went ahead and tried that, so A and B is X such that there. So we have the less than symbols and not the equal to because A and B aren't included in it. And then A and B. So here it's less than or equal to because A and B are included in the set. Alright. Now we're going to go ahead and look at, just for a challenge, kind of combining some stuff that we learned right now. Unions and intersections of intervals. So some problems to practice. If you want to pause the video after I write them and practice to check for understanding, that would be great. And then B we're going to do. So yeah, go ahead and pause the video and try these out. Okay, so we're going to go ahead and go over them together. So here we have our number line. So let's go ahead and mark 1, 2, 3, 4. And then, so our 1 and 2, that is open. And it's here. And then our 1 and 4, that's closed on 1 and then 4, and then that goes all the way there. So what does our intersection mean? Our intersection means what's common to both. So here our 1 is common to both, so we could go ahead and include that. And then the green overlaps the blue just from 1 to 2, but 2 isn't included in the blue, so we're going to go ahead and go like that. So for B, same thing here, drawing it out. And then referring to the same thing from the one above it, we'll go ahead and draw it. Okay. So this one is the union. So it could be in the first one, 1, 2, or 1, 4, or both. So 1 is in both. Then it goes to 2, but then it's the or, so it's the green also. And then it includes 4. So there we have that. And then our last thing for this video is just going over absolute value. So the absolute value of A, we know that as our A is either positive or our A is going to be a negative. So that's, oops. So these are basically like what's going to be in there. So our absolute value is always going to be positive or 0. Okay, so the absolute value of a positive A is going to equal the absolute value of a negative A, because that's just going to equal A in the end. So an example is 10 equals negative 10 equals 10. So generally what absolute value is doing is it's measuring the distance from 0 on the real line. So for example, for 10, negative 10, so here's 0, negative 10 is over here, 10 is over here. So really, this is 10 units here, and this is also 10 units here. So that's why their absolute values equal. So the formula we usually use for distance is the DAB equals absolute value B minus A. And you could notice on one of the earlier sections it stated that property of negative numbers is that B minus A equals A minus B. So it doesn't really matter which one comes first. So let's go ahead and do an example. Let's find the distance between negative 2 and 5. Ooh, that's an awful 5. Okay. So our DAB equals negative 2 minus negative 5. So we change these, and then we get Oh, I did -5. Sorry. Just forget this. Real quick, let's start again. So -2 minus 5, not -5. So we do plus, minus, so that's -7 equals 7. Okay, so that's it for this section. The next video, we're going to go ahead and go over section 1.2. See you then.